speaker for the day, we now request Mr. Ramesh Pai, DG Marketing, Nilcast Limited, to introduce Mr. Darshan Joshi, Head Southern Region, Melting Division, Plasma Induction to our audience.
I'm pleased to introduce Mr. Darshan Joshi of Plasma Induction India Private Limited. Mr. Joshi is a BE Electrical and Electronic Engineer from KLE Engineering Institute, Belgaum. He has experience of over 8 years in the induction furnace field. He is now heading the Southern Region of Melting Division at Plasma Induction. Over to you, Mr. Joshi.
Thanks for the warm welcome. Thank you, MMA and IF, for bringing up Pritika ma'am. Her speech presentation helped me ease a bit of my stage fear specifically. Thank you, Rahul from Volvo, for pointing out few points in his presentation, such as energy efficiency, plus reduce and reuse of few things. Whereas I think my presentation will be in some sort of continuation of what he has spoken in it. Just giving up a brief introduction about plasma induction, as a lot of people are getting introduced to it. Plasma induction was specifically founded by Mr. Ketan Patel in 2008 with a vision to provide energy efficient and I would say technically premium products to this industry. That is why where we started our manufacturing only IGBT based induction furnaces, and we in the year 2010 we installed our first IGBT based induction furnaces. So in today's presentation we'll be talking on two topics specifically. One is how IGBT can unlock value for your organization, and in the later part we'll be learning about LFC, loss form technology, which a lot of people might have been interested for, and I hope so that you have been into studies and R&Ds as well for LFC. So from his vision, we found out our core purpose were to provide the best, efficient and reliable technology. And due to that efficient process, we are somehow contributing to create a better world. We are somehow able to contribute towards carbon reductions. If I'm not wrong, a lump sum figure states that if a 2,000 ton per annum foundry, if they shift towards IGBT, they are able to contribute to save around 115 tons of carbon emissions, I think, which is recognized and acknowledged by BE as well. So Plasma is a group of company where plasma induction is specifically involved into manufacturing of induction heating, induction melting and hardening equipments. We also have a second group company which is Castomec Technology, where we carry out manufacturing of loss form castings. Kshitij Technomec is basically involved into vacuum segments where we manufacture vacuum sintering furnaces, vacuum melting, and New Star is all about administrative softwares. So basically everyone knows that what is induction furnace and how the process goes on. So I'll just run it through quickly. Induction furnace was founded in the year 1916. Actually not induction furnace, I would say, but the induction technology. It was founded in 1916 by Princeton, in a Princeton Palmer laboratory by Edwin Northrop, where he was able to discover that high frequency could heat the equipments. With later persistent years of development, today we have medium frequency and low frequency equipments. Compared to other methods of melting, induction furnaces has many advantages, like you can get higher yield, natural stirring due to eddy currents, compact installations, faster startups, you get a cleaner melting process compared to traditional melting, and not only solid scrap, but you can also use borings and other chippings as well. Few things you can control in induction furnace is that chemical compositions which results in low rejections. You can control the process. Slag removal process is easy, sampling is easy, batch-wise production can be set up. It's a very less polluting equipment, like hardly the pollution comes from the scrap or from the lining material which we are using. So it's we can say as a green zone product. It can be used for both ferrous and non-ferrous applications. So we are working with 7th generation of IGBT technology. Why IGBT? Most of us, we are used with thyristor furnaces. Okay, IGBTs are now developed in such a way that we find them everywhere, like right from our home inverters, UPS, to locomotives and engines. Okay, so IGBT has benefits such as it can carry higher currents, it can carry higher voltages, it has better switching time compared to thyristors, so it has better energy conversion efficiencies, and which results that due to its high current and voltage carrying capacity, there is no need of any RC circuit or snubber circuits, which somehow results in giving you better energy consumptions. As per studies, it is stated that IGBT has 3% less switching losses compared to thyristor, which directly reflects in induction furnace power consumption. So, as we were, right from the start, we were clear in our mind that we will be manufacturing only induction furnace. In the first past decade, it was quite a bit difficult for, as industries, they were like, what will be this technology, that how we can trust on it. But in the later years, in the past 12 years, we have seen that, many happy faces, that the ROI on the investment has been quite fancy, and we see happy faces when we look behind. So this is what, using IGBT, we can save approximately. If we consider a 400 metric ton month melting plant, so it is around 10,000 units per month. If we consider around 8.5 rupees per unit cost, so it is approximately 85,000 saving per month. A year payback will be around 10 lakhs. And this is also acknowledged by BEE, and they state, I'll just run through further slide. Yeah, this is what the BEE has to say, that considering 500 kg induction furnace with 2,000 metric ton year production, okay, so carbon emission is reduced by 115 tons per year, and monetary savings is 8.45 lakhs a year. Here are a few case studies. Okay, like this is a furnace which is running in Belgaum, where you can see the specific unit consumption varies between 540 to 560 units. It's a 550 kilowatt, 500 kg equipment. This is a 250 kilowatt, 300 kg equipment, where the unit consumption is varying between 580 to 600 units. This is the recent production data of IH Castings in Belgaum, where they are achieving, it's a 100% SGIRN company, SGIRN casting manufacturing company, where the monthly average, you'll see around 557 units per ton. So energy consumption bifurcation, what we have studied is almost 68 to 70% of the energy is consumed by the induction furnace or the melting area. So as it is a major electricity consumption area, we can save a heck lot of money from that department. Okay, a lot of BE and UNIDOR carrying a lot of energy awareness programs these days in various clusters. So They are promoting energy efficient motors, they are promoting energy efficient compressors. Okay, so you can also think of energy efficient induction furnaces. Okay, that is one part, that implementing an advanced technology where we can, it comes with an initial investment and which later on gives you savings year by year. But still, in an existing foundry, if you are using a thyristor furnace, a traditional furnace, you can follow these practices where you can save bit of energy. Like you can melt in optimum sizes, reducing frequency of cold starts, using of clean charged materials, short blasted runner risers, okay, reducing holding times. So there are around 12, 13 points, main points I can say, that we can follow these steps and we can save specific energy consumption right now in our foundry itself. Okay. So what features we are offering with our equipment? Okay, we are offering auto centering process where the manual centering process has been removed. You can automatically load that program in your furnace, and every time whenever you have to start centering, it just starts with a click. Okay. Power demand load manager where you can control your demands, your electricity board demands. You can utilize your plant capacity at the fullest. Data logger system where in that equipment you will automatically get data of each and every heat. Okay, after lining, how much heats have you taken? Daily, how much heats have you taken? What is the specific energy consumption of the furnace for that particular heat? What is the specific unit consumption for auxiliary or your plant unit consumption for that specific heat? Okay, so you will get all those data automatically in the PLC itself. We have developed another mobile application or a software where you can access, for example, if you are anywhere in India with an internet connectivity, okay, say suppose you're sitting somewhere in Delhi and you want to access your furnace running parameters with a mere internet connectivity, you can access those things. So this is a live furnace which is running in Belgaum where we can access and we can see that what kilowatt the furnace is running, what is the coil voltage, what is the coil current, okay. The total this is the fifth heat that is running. The furnace was started at 12:23, it's been 12 minutes, okay. And see, you can see the auxiliary unit consumption, you can see the furnace units. So you can get all these parameters on your dashboard where you can copy these data into your Excel sheets. You no need to have to maintain manual reports for it. Okay. So if you need, even you can give production plannings. There is this option where you can give production plannings to your department. Okay. So as soon as the supervisor generates a target, a cumulative graph automatically gets generated, and at the end of the day, what the melting department has achieved. Okay, so both the graphs will be running simultaneously. You can get that data as well. In reports, you can get like heat history reports, consumption reports, monthly data, okay, from particularly this date to that date. So all these reports can be easily available through this software. You can see the heat time, that the first heat took around 97 minutes, the second heat took around 59, 57. In this, you can give operator and supervisor codings as well. You can code them 1, 2, 3, 4, so you can analyze who was there at that time. Sorry for a bit of interruption. So in continuation, that we are in a stage where we look for feedbacks from our clients. So, okay, so I can say our product development comes from the shop floor, from our client feedbacks. So there was this just a small feedback that we got from our client in Kolhapur, that specifically the SG iron castings has to be poured within 6 or 7 minutes. So he said that, can it happen that a 550 kilowatt 500 kg where the batch timing should be half an hour, okay, can you give me some sort of alarms in it? Okay, we thought we could try. We could try it in an automation. So we developed a buzzer system where in that program we gave two inputs for it. One is the time input, and second is your benchmark unit consumption input. Okay, so as soon as the 30th minute starts, the furnace will start to give alarms, and that will be recorded in your history reports. Okay, so whenever the next day or the same day, if you want to have an analysis of it, you want to analyze or you want to see why it happened, so you can have a why analysis over it. Okay, and even for example, let's say you have set a benchmark for 550 or 560 units per ton. At that moment as well, as soon as the average unit consumption will cross, it will start to give you an alarm. So what will happen? It will help you to improve your productivity, the productivity of your manpower. Alternately, what will happen? Say a 550 kilowatt equipment, if it runs for 2 minutes extra, it will cost you 20 units approximately, 19 to 20 units, which in monetary terms, if we calculate, it is approximately again 190 to 200 rupees. So that will help you to analyze and improve your productivity levels. Okay. Later on in our furnace, you'll get troubleshooting guide with photographs. Okay, and you can have those spectrometer and CE meter analysis integrated with NS-Cost. So apart from IGBT, you also should think of implementing 12 pulse and 24 pulse furnaces, because our electricity boards are very much stringent towards harmonic percentages. Okay, so a 6 pulse converter gives you around 25 to 28% of harmonic distortion. Okay, whereas a 12 pulse can give you around 15 to 16, and a 24 pulse will give you as good as 8% of harmonic distortion. So these are few case studies of our clients, which they tend to say that they have saved around 40 to 50 units per metric ton when they have replaced thyristor furnaces with IGBT. 100 kilowatt. Thank you. As you can see in the crucible, okay, a lot of induction crucibles which come today, they have a front guard of cemented make. Okay, so we have developed, or we have made few changes that we have used 5 bricks in it. That the bricks which are particularly used in cupola. Okay, so they give a longer life of the front guard. Here comes the interesting part. Okay, Castromec technology, which is all about lost foam casting. So looking at the current market scenario, as Rahulji said, that sand is the major issue. Dumping of sand for foundries has been a major issue. Okay, so Castromec is involved into like LFC, where the reuse of sand is quite feasible. Almost you can reuse the same sand. Around 95 to 97% of the sand is reclaimable. No need of adhesives or no need of any binders is required in that technology to produce castings. Okay, see, I think, okay, fine. In 1980s, General Motors was the first one who used engine blocks and other casting produced by LFC process. Okay. So evolution of casting can be classified into generations, where earlier they were manufactured and they are still manufactured by green sand. Okay, then came the silicate part where the CO2 molding process came, and now we are into resins and catalyst no bake process, and LFC is the new one. Lost foam casting is somewhat similar with investment casting process. Okay, in lost foam, we are burning the wax, or we are losing, it's a lost wax process, and in LFC, it's a lost foam process. There are normally two types of foam grades which are used in LFC. One is EPS grade and one is STMMA. The main advantages of LFC is that no cores is involved, so no core defects or no core fins. Easily recycle sand because it doesn't have any binders or any other chemicals. Okay, non-hazardous materials are used due to LFC grindings, short blastings. Like those processes are reduced and you get a better finishing. Okay. Extremely low external emissions. Machinability is as good as 2 to 5 mm. Okay. Low labor cost is involved, capital cost, low area is required. Improved part performance, good surface finish. Okay. So this is a process flow of LFC. That first the EPS grade it is put up into a pre-expander machine where they are blown up to a specific sizes of grains and they are put up into a molding machine. It's similar to a plastic molding machine where you put that foam and through steam you manufacture those foam models. From there it is moved towards mold inspection, then cluster assembly. Then you have to provide coatings of around 2 to 3 mm, depends on the type of casting, how you require, or the surface finish. Normally people go up to 5 mm as well, that's the max. Okay. Then comes the foam drying process. Then you have to carry that towards the black area, which is the compaction of the mold. Pouring of metal, shakeout, degating, cleaning and finishing. This is how the process flow of LFC goes. Okay, so normally in older process, the sand reclamation, primary attrition and secondary attrition can give you around 75% of reclamation, okay, whereas thermal attrition gives you around 95%. But in this LFC, you don't need such types of things. You don't need to crush those sands or do anything for separation. So as the sand does not stick in LFC process, okay, it does not stick on the casting surface, very less energy is needed for hammering or grinding, chipping, okay, also for knockout and fettling of castings. Thus, we save the time too. Machining work is minimized up to 2 to 5 mm at tool point. Okay, the overall weight of casting is reduced, needing less molten metal, so energy is saved. Okay, LFC comprises of 3 parts, white part, yellow part and the black part. White part consists of foam modeling and cluster assembly. As I said, that beads are injected into aluminum tool and they are steamed to fuse them together into a precision replica to the finished part. Okay. This is white part equipment. This is what it looks like. A yellow part where the coating is done to the clusters and then they are moved towards a drying area. Okay. In the black part, sand filling, compaction, vacuum of the mold and metal pouring. This is how a particular LFC plant looks like. Compaction table and tilting mechanisms. So when you come to the conclusions, a summary of a process, okay, as I said, EPS, that is expanded polystyrene, and STMMA, styrene methyl methacrylate, can produce around 250 to 300 kgs of casting, a kg of foam. Okay, the costing, if you see for EPS, is around 180 to 200 rupees, and whereas STMMA will cost you around 350 to 400 rupees per kg. That per kg of foam can produce around 250 to 300 kg of castings. Difficult, intricate parts can be easily casted. Most economical process for 20 kg to 350 kg of castings for any size and shape. Okay, sand reused with only 1% wastage max. Surface finish you can achieve up to 200 RMS with good process and without any big efforts. Okay, you can achieve surface finish in between 100 to 150 RMS. And majorly, it doesn't require any core because the free-flowing sand, when you apply vacuum to it, itself acts as a core for it. This is a foam model, and later on when the casting was produced. And this is a plant actually how it looks like. Yeah. Thank you so much. Okay. Questions are welcome. For LFC, my director is here. For any questions regarding LFC, he will be there to answer you. And for induction, yeah, me and Mr. Mayu is here for your induction related queries.
Any questions, please?
Yeah, thanks. Good presentation.
Thank you, sir.
I have a question connected to loss from castings. I know there are many foundries in US specifically and in China manufacturing castings through loss from process. But somewhere I think this technology is not getting implemented in India or in Europe. Though there are many advantages on this technology. So maybe can you throw some light why exactly it's not booming in Europe and India? Specifically because India is the second largest casting producer. We make 10 million castings every year.
For LFC is like what we receive feedbacks from client is that why they don't want to invest in that technology. The first question comes or the first answer that they give is that we don't know much about the process, or the people who are using it or the people who have implemented it, they don't allow for the visits, or they don't allow you to study that how the process flow works. So most of the people who have implemented this technology, either they have studied it for somewhere around 3 to 5 years, they have visited China, they have visited some out of India, they have visited few plants, then they have come to India and they have implemented this process. So it is like here it is still not much open, or they are not like comfortable to share that technology with each other. They want to be the first, that I'll be the first, I'll cater the first for that client specifically. Yeah, please.
I would to like invite all of you, if anybody is much knowing about LFC and this process, or seeing the process or equipment, you are all welcome to our plant in Ahmedabad, Gujarat. Anytime you make a call or mail me, I will share my contact details to all of you. So we will try best to implement this technology in India, and it's a very, very good benefits of this process and cost effective. Many of clients are using this technology in India. Almost 7 to 8 people are very good job and production and get the benefits of this technology. I think all of you are knowing the Porval Auto in Indore. Mr. Deven Jain, they are using this technology from last 3 years, and he is achieving a good benefits and production up to 120 ton per month. So it's easy to implement, nothing to do is very difficult, but is fear in our mind and our thoughts. So we take approach and implement or implemented this technology in our foundry industries.
We will build it, we will operate it, and we will transfer it.
Thank you.
The major region which is exploiting LFC process is Rajkot. There are many installations which are coming in Rajkot specifically into LFC. And we have came with that approach that you don't worry, we are here, we will build it, operate it, and we will transfer it to you. Yeah. So,
Which cost? Total cost of you require machineries and which casting you want to produce. If you have a single parts or many parts you want to do, it's SG iron, ductile iron, cast iron or steels, depend on like that. But we talk about CI and SG or simple casting of valve body and motor body and something automotive engine blocks. That's 100 tons or 200 tons. It's cost roughly about 3 crores approximate. Yeah. All the equipments. Yeah. All the equipment. Not much. Raw material is easy available. Right now we are depending on importing this good quality of raw material of EPS and STMM. But now many manufacturer or Indian manufacturer are coming up to establish the plant of this raw material manufacturing in India also. Approx is costing down to approximate 25% of reduction of cost compared to conventional methods or process of green sand cast or high pressure molding line.
He's asking if more foundries do this in the future,
Yeah.
will the overall cost come down?
Yes, yes. Yeah. Right now we are also depending some parts and some raw materials from out of India. So when the more foundries is come down in this technology, it's very make in India and this equipment, so cost is down.
As the raw material manufacturing will start in India, I hope so the prices will reduce bit good. Yes.
Substituted with the PMMA, polymethyl methacrylate.
So,
Styrene methyl methacrylate is what is shown in the slide as a raw material which you said you have been now importing it. Will that get replaced with PMMA, polymethyl methacrylate? Will that be a substitute for that? I'm not sure about that.
Research point this one. Actually we are using the STMA and EPS is comparing to low carbon generation in the castings. If you are using the EPS is every materials. EPS has own properties of polyene gas and the carbon generation gas. Yeah. Yes, easy available and is low cost. Yeah. But we yeah. Maybe, but it's take a time, not easy. Yes. No, but when the form is burned. Yes.
It is toxic, right?
There are the molding line, and up of the mold we are put the extraction system of fume. So it's extract and purify in water, and then we suck through vacuum pump.
You have to put that dust extraction system, fume extraction system through water bed. Yes.
Thank you very much, Mr. Darshan,
Yeah. Thank you so much.
for an excellent presentation. We now request Mr. K. Balasubramaniam, past chairman, Southern Region IEF, to felicitate with the traditional Angavastram, please. We now request Mr. K. Dayalan, immediate past chairman, Southern Region IEF, to felicitate Mr. Darshan Joshi with a memento and a foundry encyclopedia.